All right, welcome to today's veteran workshops for CAD. All of you know me at this point, I'm Tamara. And we're going to be doing a little bit of work on that gearbox that I had all of you download. So just as like a brief overview of how these workshops are going to go, I'm going to try to structure it as a day with parts, a day with assemblies, a day with drawings. But since most of the people in here are seniors or juniors and pretty much everyone here is a veteran, I did also want to use this workshop as a chance for all of us to discuss how we're going to use organization of the Onshape and I guess delegation of Onshape's resources and features on our team. Part of the reason for that is I did speak with a few of the mechanical mentors from last year, and they've noticed a few patterns of, I guess, things like improper mate usage or just like CADing things without considering design intent. This isn't like me trying to hammer on any one person. I had that issue when I was a student as well, but this is, I guess, a workshop for us to consider how we're going to implement CAD on our team as well. Exactly. Exactly. I know that Onshape mates in particular tend to be a really big problem because, like, if you're not that familiar with Onshape, which again none of us were last year, it's very tempting to just use fasten for everything, and that actually does cause everything to become overdefined. Like it's basically fixing it. So it gets bad. So does everyone have the dual speed gearbox downloaded? Cool. Yeah. And I guess, does everyone have it like uploaded to? That's a great question. So here's what I'm going to do. I'm going to create a new folder. I'm just going to call it. So what I'm going to do is I'm going to say import files. And I'm going to go through my downloads, and I picked a bad day to install ANSYS. Where did I leave my? It was in here somewhere. Here we go. I'm going to pick the step file 217.3423 West Coast Products DS dual speed base kit. And I'm going to say import into a single document. Oh, of course. So create, import files, and then your downloads tab is going to pop up, and you're going to put your, basically you select the file that you just downloaded, the step file. Yeah. So it's going to take some time to translate, but I guess while that happens, just to explain, Onshape is relatively new as a CAD software, so it tends to not interact very well with a lot of imported parts. It tends to interact very badly with like assemblies in particular. So now that we have this installed, imported, let's see why I was telling you it doesn't exactly translate well. Oh yeah. So this looks fine, right? I mean, look at this. Look, this is all fine. And if I click on this piece and I drag it away, oh, that's not good. Yeah, this is not good. It's flying away. So you might have gone to CAD imports and clicked on this guy. What you want to do is actually click on that home tab and click on the step. And that's how you fix it. So yeah, this looks okay, right? But I noticed that you can just sort of, pull that away. That's not quite good, we don't really want that. So there is a discussion to be had, and I believe it has been happening on CAD with whether or not you just group everything together. I think for assemblies like this in general, that's probably the best, just because this is a big assembly. There's a lot to assemble in here, and unless you put it together pre-season, it's going to take a lot of time. Yeah. Oh, sorry. Was that your hand? Or? Sorry. Yeah, no, sorry. I just saw this and I'm like, oh, okay. But yeah, so I guess the reason I had you download this is because there are a few things I want to do with this gearbox over the course of the next 3 weeks. So gearboxes in particular feature a lot of design intent. It's not just about dimensioning something the way you want it. You also have to know dimensions relative to each other. This gearbox plate, for instance, you're not just creating a plate and putting holes in it. You also have to know exactly where your gears are going to go. You have to know how far apart or how close together they can be for them to still work properly. And all these lightning holes here, you have to know what parts of the gearbox need support and what don't. As you can tell, the holes over here are what need support. For obvious reasons, they have giant cutouts already. So yeah, I think what we're going to do today is we're actually going to remake this gearbox plate. And we're going to go over a few of the features with that. So for now, if all of you have this open, we're going to create a little folder in here, and I'm just going to rename this workshop folder for now. And what we're going to do today is start off by going through the steps of how we might make a gearbox plate like this. So I'm going to click on that folder, and I'm going to click the plus sign and say Part Studio. All right. So there is one thing we need to do before we get started. And this is just a really quick tidbit that'll help us with the sketch along the way. Every single gear in here has a part number attached to it. And you'll notice that in the part number, you're saying 60 teeth, 44 teeth, et cetera, et cetera. But you'll notice that in order for all of these gears to work together, what do they have to have in common? Thickness is one thing, sure, but there's a really important thing about the teeth specifically. They don't necessarily have to have the same teeth count, but they have to have the same. So you're kind of on the right track. You're on the right track. Exactly. And for that to happen, they have to have the same teeth per inch, right? So same diametral pitch. So because all of these gears are going to have that same teeth per inch, we can actually turn that into a variable and use that for sizing. So to show you how to do that, you'll want to go up to this little corner right here where you can create reference planes, and you're going to select variable. So in our case, we have roughly, I think it's 20 teeth per inch in this model. So, oh, of course. So reference planes are going to be sort of in this corner right here. It's going to have this sort of icon with a big plane and a little plane inside it. And you'll scroll down to where it says variable and you'll select that. So if we have 20 teeth per inch, how many inches do we have per tooth? I'm going to get into creating this guy. So we're going to click on sketch and let's use the front plane. I guess that makes sense, you know? So normally in the rookie workshop, I told students that would be good to reference things from the center point, like the origin, since if you're having everything be symmetric, that's just a good thing to have, reduces the amount of time you have to spend adjusting. So what if we didn't use the origin as the exact center of the part? Think about it like this. For this gearbox, the relevant point isn't really the dead center of the gearbox. It's not right here. If anything, it's actually right around here where the two motors sort of meet together and power that center gear, because that's where all the power is. Yeah, exactly. But we still don't know everything we need, right? Because we don't know how wide and how long we want this to be yet. We need to determine that based on all the parts we're going to put in. So that's where we're going to get into a bit of parametric modeling. What I'm going to do is start by creating a bunch of construction circles to represent the gears and their placement, since again, everything is relative to gears in this case. So I'm going to start with the circle over here, and that's going to be that little top shaft thing that we have going on. So I believe that the main gear is going to be 42 teeth big, and the two driving gears from the motors are going to be 14 teeth. So for now, what I'm going to do is create a center point circle over here. Oh, whoops, that needed to be construction. We're going to create a construction circle here and another one here. The dimensions are going to be a bit off relative to the other one because the other one offset their motors a little bit, but for now, we'll just stick with this. And we want to make sure that these two circles are equal, the left and right one, because those are both the spur gears coming out of the motor. So we remembered that we wanted those two spur gears to be 14 teeth. So let's dimension them as such. We're going to click on dimension, click on one of these circles, and we're going to put in 14 teeth times 0.5 inches per teeth. So 14 times hashtag TPI. Because remember, TPI is that variable we created. And that'll do the math for you. And then we need to do it for the center gear as well. So that's going to be 42 times hashtag TPI. Does the math for you. So now if we're going to switch over to maybe 15 dp, all we need to do is change that variable and we'll do the math for you. TPI, that variable you created. And remember, it's going to be hashtag TPI. I feel like there was a word for hashtag before it was hashtag. Was it pound? Yeah. I'm going to start saying pound again. I'm going to bring that back, take it away from Twitter and stuff. So I guess let me know once you get to that point. So we don't just have two motors driving in an individual gear. That individual gear is going to have a smaller gear attached that then powers a larger gear, and that's our output, because 3 to 1 is not enough for 2 motors. So we're going to create 2 more reference circles. So now we're going to create a little circle in here and a big circle out here. And in case these two aren't touching or they're overlapping, you can always go to tangent and select the 2 circles so that they're always going to be in contact with each other at one point. So I'm going to quickly check over here to verify the size of that gear. And I believe that's a 14 tube. Yep. And for verify 16. Okay. So we're going to go back over here and we're going to put that in as well. This little one is 14 teeth. So we're going to put in 14 times pound TPI. And then over here, 60 times pound TPI. And there we go. That is roughly all the gears we're going to have. Again, we're not going to fully design and assemble this the same way as them. We're just going off of spacing and parametrics here. But again, as you'll observe, pretty much every effective dimension here is not just based off of an initial box that you then size everything in. In this case, we want the box to fit everything that we have sized, because again, these dimensions are more important than the outer dimensions of the box. Yeah, because again, right now we're looking at it 2D. If you look at the original, a 2D view will show that these 2 gears up and down are overlapping, but then if you look at it from the side, they're not, because they're offset from each other. That is a really good question though, and that is something to keep in mind. So with that, I think we have most of the driving dimensions of our gearbox plate. So we're actually going to create the sort of box for it now. So we'll use that rectangle tool. We could do center point, but then that's going to constrain everything relative to whatever we pick as our center. So actually, yeah, let's do that. And remember, we're not picking the origin to start this off. We're picking somewhere down here. And we'll sort of go up and out like that. And then just sort of drag it to wherever you think is roughly good. Again, try to avoid touching anything or snapping to anything, just because we don't know if that's what we want yet. And one more thing we do need to consider, we do have all these gears. We also have motors though. So I'm going to create 2 more construction circles to represent our motors. And we're using 2 sim motors. So what we're going to do is we're going to size those both to, I believe, 2.5 inches. Yeah, I think it's about 2.5 inches. So now this little box we created needs to sort of be at most, like at least tangent to all of these circles. We do want a little bit of offset, so let's see how that works out with our dimensioning right now. So let's say I want to make this 5 inches by 5.75 inches. But let's say we also want to know all the dimensions. So I'm going to set this distance from the center at 1.5. But let's say we also want to know the distance of this from the bottom. Let's say this also matters. So you'll notice that it turns gray right here. this is what's called a driven dimension. This dimension, if we want it to be bigger, then we're going to have to change one of these accordingly. So if we want this to be bigger than 1.65, I'd have to change that to say 1.25, and then that changes. And what that can do is help you visualize dimensions that you need to know without necessarily defining them based off of that. Again, it's a really good tool for visualization, but in that case, I did something wrong. That's probably fine. I think so long as you're, oh, here, I'll zoom in. If you want, you can sit closer also. Oh, that would do it. Yeah. Yeah, it's okay if the outer dimensions are a little bit off, I think, so long as your center distances are all okay. Because again, like the driving dimensions here are mainly the distances from the center, not really the dimensions of like the box as a whole. So I think that's fine. We'll see how it goes. Yeah. So now we can actually extrude this. Or do we want to add the shaft? No, let's do that later. So now we're going to extrude. And you know the drill, 0.25 inches. In this case, since we are using a face as like a mating surface, I am actually going to say that you don't want to do symmetric in this case. And now we're going to check it off. Now, before we go any further, just to check, does anyone have any questions? I'm seeing some heads shake, that's good. Okay. So before I move any further, I do want to set the material of this part so that we can actually check material properties down the line. So I'm going to right click part 1 and say assign material. And then we're going to sort of go through the on-shape material library for now. Let's see. Do you want to do aluminum foil? I don't want to do aluminum. Yeah, I don't want to do this. I just noticed it. We're going to go with some 6061 aluminum. A nice, I'm not sure if it's the cold forge or the hot rolled. I don't know. I saw among those numbers, but yeah, aluminum 6061. And I'll show you why that's going to be used later. So for now, I'm going to set this sketch to visible because, yes, of course. Right click part 1, say assign material, and then in the drop down under on shape material library, you'll select aluminum 6061. It's a little bit weird to see because the default is on shape material library, but then the default under that is just blank. So it looks like you're not selecting anything, but you are. Great. All right. And again, I am going to send out a recording of this. So if you missed anything, or if there's anything that we don't have time for and I need to add on, I'll add it on at the end of the video. So now we need to create the cutouts for the shaft bearings that are going to be there, and for the motors and other mounting holes. So we're going to go back into our sketch tool, and you'll want to make sure that sketch 1 is selected as showing rather than hiding, because we are going to be referencing this a lot. So first, we're going to start off by putting in the holes for these 2 bearings, since those are some important shafts, and we'll put in the holes for the motor as well. So as always, we'll start with the center of the hole and we'll go out. And we actually, let us also use the fuse tool to actually bring some of these points out onto the sketch. That just sort of projects from a different sketch. So in this case, we want to keep these points as part of the sketch. So I'm going to select use, so that on shape knows the center points of sketch 1 are also points we want to use in sketch 2. You don't always have to do it, it just helps. Of course. So to repeat, we're going to click on this box, use, and then you're going to click on the 3 center points. Yeah, I think they did have convert entities, but I know that, yeah. We did not. I think I kicked the dinosaur. I will put that back up later. For now, I'll move her over onto the side. all four. So yes. No. Yeah, because the origin is going to be selected no matter what. Yeah. Onshape's just kind of weird about what it allows to project and what it doesn't. So generally I say, just in case, project it. All right, so normally I would say to have the two bearing holes be separate from the holes for the motor, but I think in the space of time, let's just do all four of them together. So let us create some more circles. And again, since these two are both for sim motors, those will be equal sized. So let's start sizing these holes. I believe the center hole was 0.874 because it was the outer dimension of the bearing, but slightly undersized. So 874 inches for that upper hole, 1.125, 124, sorry, it's undersized for the lower hole. And then 0.5, I think it was for, it seems kind of small. Let me check that again. That doesn't make sense. Yeah, that's small. Let me just make sure. Measure. Okay, so I think that's actually 0.75. Yeah, that's actually 0.75. My bad. And that's why we do things in folders so that we can actually go back. Hi, Aiden. All right, so then once you have all the holes dimensioned, we can just extrude these. Sure. 0.874 for the upper hole, 1.124 for the bottom one, and then 0.75 for the two holes representing sim motors. You just missed the part where we did variables. Okay. Yeah. Oh, one thing to mention, the reason these two holes are 0.874 and 1.124 is because if you'll notice, these are actually a little undersized from the bearings. Since they're press fitted in, you undersize it a little bit. Yeah. Yeah. We just went over like the more parametric design aspect of it, so you did not miss too much. I'm not sure why I'm telling you this. They are different. Good point. So to go back into here. No, you're absolutely correct. So yeah, this is the upper shaft. If you measure that really quickly. Oh, you all know about the measure tool, right? Just making sure. So if you measure that really quickly and you just select that outer point, yeah, the diameter is basically about 3/8, and the other one is half. All right, so we're going to go ahead and extrude that. And as you remember, if you have multiple separate faces within a sketch, you can just select all of them, or you can select the sketch itself if you want all of them. And we're going to go through all. After all, this is a gearbox plate. So we now have 4 of the main holes in the gearbox plate itself, and we are going to add in the mounting holes next. But there is one thing I want to bring up first. We established a material first, right? So let's look at the material properties of this. This plate, before we add in the mounting holes, is 0.645 pounds. How many of these are we putting for each gearbox? Yep, and how many gearboxes do you normally have on your drivetrain? So doing some quick math, this is going to be a little over 2 pounds total. Let's see if our lightning holes are going to lighten this, like their mounting holes are going to lighten this up a little bit. Hopefully they should, but let's find out. Or can we? You're about to find out. So we are going to do that towards the end of this workshop. And I guess as a disclaimer, I am going to ask that you try to lighten the ears up further for homework, but for now we're going to go through this. Yeah, Sam knows there's homework. Yeah, so I guess as a sneak peek, this is what I'm going to hopefully. So the main T-tool I'm going to show you is going to sort of, again, depend on the outer geometry, but you can get fancy with it if you want. So for now, let's just, ooh. Okay, I guess I'll show you the one that I was working on for practice. So this is what I ended up coming up with just for practice. Yeah, so I'm going to show you how to do this. Again, this is mostly just based off geometry, and you can go further. I can see area up there and down there that I can take care of as well. But I'm going to try to get you at least through this part. So, where was I? I was here. So let's actually start adding in the mounting holes. So sketch. Now, as you'll remember, 2 of the mounting holes are going to be for the motor, each motor. So thankfully we have these 2 circles here to reference where the motors are. So I'm going to start again, as I often do, with some construction circles. And I'm going to put vertical lines through them to indicate where the motor's mounting holes are. It's okay if they're not perfectly vertical, just make sure they at least go through the center. Because you can always set them as vertical later, but setting them as going through the center is a bit weirder. Oh, that one needs to be construction, and it needs to be vertical, as does this one. And each of these circles, I believe, is going to be 2 inches, because that's where the mounting holes for the motor went. Oh, what am I doing? I already think this is equal. Oh, no, I didn't. Interesting. And then we'll just put some holes there, except all the holes we're going to put in are actually going to be about 0.2 inches. So we can actually define a variable in here to make that happen. For sure. I'm going to get rid of that. So we have all these relations here. You can click on vertical and then select the line. And that's all it takes. Yeah. And for now, I'm going to show you how to create variables within Sketch, because I believe that is something we can do. Yes, we can. All right, so let's say hashtag and then create a new variable. I'm going to call this one diam and make it 0.2 inches. There we go, because we're going to have a lot of 0.2 inches. Let's see, do I want to add the full pattern around here? So I'm debating whether or not to have all the holes down here, because while a lot of them, okay, so there are 3 that I want to put in there. The other 2 are for holding the bearing in place. Yeah, okay, let's do that. Yes, and you'll want to create that as a new variable in the sketch. I called mine hashtag diameter. All right. I'll show you. So if I want to dimension that hole, I can put in a hashtag and then say new variable. Yes. Anyways, let's add 2 more holes down here. Now you'll notice that 2 of these holes are going to be relative to a plate that it holds the piston for the dog shifter in place. So we can actually create that ourselves. The plate, because you'll notice that there is a specific dimension between those 2 holes that we need. So once again, you're going to be using the center line because everything in Onshape and parametric design comes back to the center line. Just because, you know, it's convenient to have. So I checked in advance and the holes at the bottom are about 1.25. So we are going to do midpoints, select that center point, do that. And now we're going to dimension this line at 1.875. And that's pretty much all we need for these 2 mounting points right here. There are 3 additional holes for putting the bearing in place, and I guess we could add those in, but in the interest of time, nah. I should have add one in. Okay, and hashtag diameter, and set these two as equal to each other. There we go. So do we have any more holes we need to do? Cool. Yeah, I think we can skip the other two. Yeah, let's skip the other two. But don't we also need the, no, there are two more mounting holes we need. My apologies. Let me check the dimensions for those real quick because I did not write them down. Sorry. Does anyone have any questions so far though? All right, so we're on the home stretch of things. Yeah, I'm adding the two last mounting holes. Sorry, I should have said so out loud. But yeah, we're adding two more mounting holes at the corners. And let me just mirror that over for simplicity. Mirror line center, mirror that. Okay. And that should be the final few mounting holes that we need. So I'm gonna hit the check mark. Yeah, oh, let me show the sketch again. I guess give me a thumbs up once you have all the dimensions. I left out 3 of the holes because why not? But yeah, these are the main holes that we need to take care of. The other 3 were just for holding the bearing in place, so I figured for the sake of the workshop, they're not as important. Oh, here, let me put in a driving dimension just to show that. They are equal distance from each other. Yeah. Oh, sorry. Yeah, I mirrored it. You could also just create a 4.5-inch line and then have those 2 circles at the end of that. Yeah. You don't have to follow what I'm doing to a T, just as long as you end up with like the same dimensions and relationships. Because again, what's important with gearboxes isn't just like you have a box and you fit everything in there. It's where do things go relative to each other. So as long as you have the gear dimensions, then you'll probably be fine, is the way I see it. As you know, we can't just go willy-nilly cutting holes out of this because you do need strength around the bigger holes that you already have. Hi, everyone. So normally I would just tack this onto the end of the video after also showing the full recording, but because the last bit of the full recording got a little bit chaotic, I thought I would sort of break it down step by step and then just replace that part of the recording with this. So the last thing we need to work on for this gearbox is actually creating some lightning holes to sort of lighten, you know, this plate itself. So to demonstrate how I did that, I'm going to delete the lightning holes I made. And you'll notice that if we just take the mass of this plate, it's going to be 0.639 pounds. Now, 0.639 pounds for each plate, but there's 2 plates on a gearbox. So it's going to be about 1.28 pounds or 1.3 pounds. And you have 2 of these gearboxes on a robot. So that's a little over 2 pounds total. You know, that's a lot of weight. And you do need to spare every pound when you only have 120 of them. So we're going to work on some holes to lighten this up. So there is a bit of rhyme and reason to where you can cut material. Normally, you want to leave some sort of strong border just so that the gearbox plate can maintain its shape. And you also want to be careful to maintain structure around these holes right here. Particularly the holes that are going to have bearings mounted, and particularly holes where you're going to have some sort of physical interface. So even holes where there's going to be bolts do need to have some level of structural integrity, right? So let's start cutting some holes out. So I'm going to start with the sketch on this plane. And we're going to focus primarily on this left half and then mirror it over to the right, since that makes the most sense here. We're symmetric about the left-right. So I'm going to start by actually using the project/convert feature to bring these holes to the sketch, because again, these are going to be relevant.
I'm also going to create, well, actually, I'm just going to use the use to bring this motor circle to the front as well, because maybe we're going to use it for our sketch, right? After all, that is going to be a physical interface attached to the gearbox. So for starters, it's not just this region right here we want to leave alone. There's roughly a border around it that we just do not want to touch, right? So we're going to use the offset in order to, well, make sure that there's that border. So I'm going to hover over and I'm going to select that. And I think that direction is fine. So I'll click again and I'll put in the thickness. And you know what? We're going to be putting in this number a lot and maybe varying it a little bit. So you could use a variable for this if you want. For now, I'm just going to use the default 0.25. And we're going to do this over here as well. Again, this hole is really important because it's actually going to hold a bearing. So again, 0.25 inches, go. And then we also have holes here and here that matter. So again, we're going to create those offsets. I'm actually going to make this one 0.125 because those holes are a bit smaller, so you don't need quite as much border. So again, 0.125, and feel free to use variables for this part if you want. It is a bit easier to do than just manually clicking on everything. Now for this one, I actually want a bit of a border as well, because there is material in here that we can cut out, but not too much. Let me show you the reference here again. So as you can see, the gearbox plates here are roughly on the edge of the motor, and there is material taken out on the inside, but there is still a border around the motor and there is still material on the inside as well. Sorry, my mouse is moving all over the place. So with that in mind, that's how we're going to do it on our part as well. So I'm actually going to turn this into a construction circle, and I am going to create some circles. Well, I'll just use the offset again. So I'll offset this one and sure. Oh, whoops, went away. That's odd. And yeah, that works. And we're going to make this one 0.125. Or actually, you know what? We could just, no, that's good enough. And we're also going to offset it in the opposite direction. To make it opposite, we click on the arrow, click anywhere. And again, we're going to go 0.125. That doesn't seem like much. We might go back and change that later. This is a little bit odd, I think. But we'll leave it like this for now. And we'll see how it turns out. So let us now actually start connecting all of these holes, because again, we're not cutting this one out, we're not cutting this one out, we're creating cutouts based off of these circles. So to create those cutouts, we're going to use the line tool, and we're going to go from one circle to another. You're going to be able to figure it out sort of intuitively, like if you're connecting these two small circles over here, then any circle that the lines go through is going to be connected as well. So yeah, let's make these tangent for now. Again, another way you could do it is to just, well, let me make them vertical. You could just make both lines vertical and equal in length, and then you could make them a certain distance apart from each other. That works as well. But I'm just going to make mine tangent for now because it's a bit easier. And then tangent, tangent. So be careful about that. It is possible that you've overdefined it somehow. So I'm going to do it again with the tangent mate. Yeah, so it looks as though this equal mate is causing it to be overdefined. So let us see how we can drag the line. It doesn't look like we can do much. So for now, I'm just going to delete that line and try again. Okay, so we're going to go from here to there. And we're going to make this tangent to that. And it's defined. Perfect. So that's one thing. You could also have another web going across, and you know what? I think I'm going to do that, but it's not going to be as thick, I think. So I'm just going to go ahead and create a little reference line going from here to there. And I'm going to create a line like that, kind of going the same way. And then I'm going to create one on the other side. And I'm going to have those lines be equal length as well. And I'm also going to have them both be strictly horizontal if they're not already. All right. So now I can just define the thickness between them, and that should be good enough. And again, I'm not thinking they need to be too thick. I'm just going to make it 0.25. All right, there we go. Yeah, so again, this webbing can probably be made a bit thinner. You can add a bit more meat over here. It really is up to you and up to what sort of structural analysis program you're using. I don't know if we necessarily use one on the team. I am looking through Onshape to see if they have any packages built in. But the idea here is we only want to remove so much material that this is still structurally sound. You know, we don't want to remove everything here. We want to make sure that there is support where support is needed. So with that in mind, let's show you what regions we're actually going to cut out. And we're going to do that using the trim tool. So intuitively, this region on the inside is going to go, this region on the inside is going to go, this region and that region as well. It's a little bit hard to see right now, so let's clean this up. So we're going to get rid of these because obviously these aren't going anywhere. We're going to get rid of this as well. We're going to sort of go in here, get rid of those. And hopefully this should be cleaning up a little bit right now. Still maybe a little hard to tell what we're going to cut. So we're only cutting this area. So with that, we're going to get rid of this and that. And we're going to get rid of this and that. We're also going to get rid of this. And we're going to get rid of that. And we're also going to go ahead and get rid of these. I know it seems like we're removing a lot here, but do you see how these regions are starting to show up? We're going to do that here as well. Cut, 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 cut. And we're just, cutting all these. And if you get undefined areas like this, you can just set them as, equal to each other, and eventually it'll kind of even out. You could even just reconnect them using the construction lines. And then you should be able to sort of reset some of your established dimensions. We're going to make those equal again. We're going to make them horizontal again. Because again, some of those constraints are probably gone now. Yeah, see? Horizontal. Yep, there you go. So see, that's how you can regain constraints if they go away somehow. So now we still have some more cutouts to clean up. As you can see, there's one right here that needs to be cleaned. I'm going to clean it out as such. And we're also going to clean these areas on the inside. Now you can start to see what exactly we're cutting here, right? Because now we do have these defined cutouts. And now it's looking a lot cleaner. So we are cutting only these sort of 4 quadrants on the inside of the circle, if that makes sense. And we can also probably remove more. We could probably even like cut this whole area out. As a matter of fact, I think we'll do that next. But for now, we're going to mirror this all onto the other side, select this mirror line, and you can kind of click and drag this box if you want. And that should all mirror. There we go. Now you'll need to do some more trimming again. For one thing, we forgot these lines in here. Whoopsies. I mean, it's not going to extrude anyways, but just be careful. Because if you select the entire sketch instead of just selecting the regions you want, it might give you some grief. And as you can see, we have a problem here again. So we're going to say vertical, vertical, then there we go. Those points are undefined, but we can probably delete them because like they're not really connected to anything anymore. Yeah. If not, then you can just leave them there because again, they're not going to affect anything on the sketch. And is there anything more we can do? Yes, there is. We can even kind of go from here to there. Isn't that looking better now? And let's define that distance. We want to have some thickness there. Let's call that 0.25 as well. And is there anything more we can remove? Actually, you know what? I'm not liking the shape of this. I'm not liking the shape of this. What we're going to do instead is we're going to make that tangent. There we go. And we're also going to add a line on the inside and then just remove this excess right here. And now we're going to make that webbing 0.25 inches thick. 0.25. There we go. And just to make sure that it's extra clear what we're trying to do here, these go away. And we are going to be trimming the areas now. So I'm going to hit the check mark. And if it's not clear to you yet what we're going to be trimming, let's show you. So first of all, click on remove and then start sort of hovering over the regions. And you should see that cutouts are starting to form. And let's rotate our view just to get a good look. What do you think? Let's find out. All right, so now we have some lightning holes. Let's see how much this actually lightens our structure. And that's quite a bit. That's about 0.1 pound down. That's actually gonna make a difference of about half a pound once we add all the 4 plates together. That is something. And again, we can keep going. Like you can even take the fillet tool. Where's the fillet tool? Sometimes I forget myself. This is not my first CAD program. It's like my 5th. And I use something different for work. So sometimes I'll forget as well. If you forget, that is no shame to you. Let's try doing 1 inch. Yeah, okay, that's something. We can probably go further. I feel like this is a workshop where I keep saying we can go further. Anyways, as you can see, we now have this sort of nice removed material here. Remember, fillets don't always add material. Sometimes they can be used to remove. And I'm liking this. I think this is quite a bit lighter than it was before. Let's confirm. Yeah, we've lost even more weight just now. So again, part of why we want to add fillets and curves to things is that it does help with stress concentration. Stress concentration tends to be highest at corners, especially sharp corners. So when you have something rounded out, not only is it a bit, safer in terms of inspection purposes, but it's also going to help sort of distribute that force better along the material. So I guess as a reminder, your homework is going to be to finish cutting out lightning holes. Make sure that these holes are all given some level of protection. And my challenge to you is to see how much material you can remove. All right, thank you and good night. And I'm going to stop recording now.